I have here a web application written in Haskell that lets you leave comments in a page. It's a very simple application. It doesn't even have authentication yet, but it does have persistence using a pool of Sqlite connections. And the configuration for the application is likewise very simple. It's a YAML file where you specify the port, the location of the Sqlite database, and the size of the pool. So when you have to decide on the overall architecture of a Haskell application, you have a number of options. You may go with an effects system, or you may go with a monad, some kind of monad stack. A common solution is to use the reader T monad transformer over I/O, where the reader T carries like some environment. But I wanted to try something different, something perhaps simpler. I wanted to structure this application as a number of records of functions, where the functions are effectual functions that work in I/O. I didn't want like any transformer in the big picture, so to speak. If any particular library that I use uses it, okay, but in the big picture, I want to simply use I/O. What I mean with this is like something like this. Consider this data type is a record where the functions, where the fields are functions living in I/O, having effects in I/O, and basically this record represents like a kind of interface, uh, an interface for a repository that lets you store and retrieve comments. Okay, this is not unlike like an interface in object-oriented programming. Okay, so if this is an interface, what is an implementation? This is like an implementation of the repository interface that stores the comments in an SQLite database. And an implementation is really a constructor function that returns a value of the repository. And in this case, we have some dependencies. We have a logger, which we use here, and we have, of course, as dependency, a connection. More precisely, an I/O action that returns the current connection that we then can use to store the comments or to retrieve them here. And notice that the dependencies of this implementation of this constructor function are passed as plain function arguments. Like in other approaches, perhaps the logger and the I/O connection perhaps could be stored in the environment of a reader T transformer or something like that. But I wanted to in this application, I wanted to experiment with passing them as simple, plain function arguments. Okay. So this is a possible implementation of the comments repository interface. What will be like a different implementation? Okay, this is one. This is an in-memory repository, which of course uses some kind of mutable reference to store in memory the comments. Notice that this constructor is effectful in the sense that before we get the comments repository, we must perform an I/O action. Why? Because it needs to allocate the mutable reference, and of course, new I/O ref is itself an effectual function. Okay, now that we have decided to structure our application in this way, that raises the question of, okay, if the constructor functions like take dependencies as arguments, who passes those arguments and where? A possible answer to that is that you pass those arguments. And where? At a place called the composition root of your application. The composition root is some module that sits like close to main, where that knows all the constructors of all the components, and in which you manually like wire each constructor, like passing, executing it, then taking the result and passing it as argument to another constructor function until you get until you wire your entire application. You can do that. You can wire things manually, but I'm going to take a different approach. I'm going to use a library called Cauldron, which is a library for dependency injection that in some way automates the process of wiring the constructors together, and it provides some extra niceties uh, for the wiring process. But this is just a pet project of mine, which hasn't seen like much usage. It's mainly for my own amusement. But there are other libraries called like registry, uh, which follow a similar approach and are much more mature. But I'm going to use Cauldron because it's uh, my library. Okay. So I'm going to go to the root module, and this module is a composition root. Here we will wire all the components of the application together. And we'll do that by throwing them in a cauldron. What is a cauldron? It's a map of recipes. It's a map of all the constructors in the application, and once it has all the constructors, it will wire them according to their types. So Cauldron assumes that there is at most one component of the application with the same type. So there will be only one comments repository, there will be only one pool, and with this assumption, Cauldron knows which arguments to plug in because it indexes all the recipes by their types. And Cauldron, the recipes that we will put here, when run, have effects in the managed monad. And what is managed? It's a monad for structuring like resource acquisition and release. I have another video about it. You can watch it if you wish. Okay, so let's begin. So the entry point in our application is a component called runner. Here, which is simply like an IO action, but we wrap it in a new type for clarity. Basically, this is the action that we want to run when we launch the server. And here in the same module, because we could put this constructor in another module, but because there is only one implementation, so we leave it here. Here is how to construct a runner value. There is a runner conf, which is simply basically the port and has a from JSON instance. There is a logger. There is something called an application. This is a wrapper over the way library application type, but it's a wrapper over it because for technical reasons, the application type in Y is itself a function, and Cauldron doesn't work well when the final product of of a constructor is a function. So we wrap them in a new type. Okay, and basically runner, what it does is simply, well, it logs and uses ways the warp server function run, which takes application and runs it. So not a lot of mystery. So I'm going to put this constructor in the cauldron. I can do that directly. What I need to do is to write recipe. I pass it the type of the component I want to add, and then I must clarify if this constructor is effectful or not. Remember that we saw that some constructors were effectful in that they perform some action before returning the component. This one doesn't. And we don't need to, when the constructor is not effectful, we indicate that with this function called val. Okay. So val, what it needs is a value of type args runner. And what is args here? Well, it's a reader-like applicative which reads values from a dynamic environment of the dynamic values. So, for example, if you need what a type of a value of whatever type, you use the arg function here, which simply looks for the value of type A in the dynamic environment and returns it. And of course, it may fail because it may not exist. So my library cauldron wires things at runtime. So how to construct the args value, args runner from the constructor here? For that, there is a function called wire. And well, let's, okay, now it compiles. And wire performs a little bit of magic. It simply goes through the constructor definition, like the constructor signature, takes every argument in the constructor and moves it into the args applicative, like it reads it from the dynamic environment. Okay, so when we want to put something in the cauldron, we put recipe, we specify if it's a pure constructor or not, and then we wire the constructor and put it here. So a nice property feature of Cauldron is that it lets you see the diagram of components as a graph while you are building it. So I have here, okay, a diagram of the components in the cauldron, which of course right now there is only one component, and these things in red are the dependencies that do not exist yet. Okay, so which, if you look, are the arguments of the constructor here. So what we need, of course, is to provide these dependencies. I'm going to begin with logger because it is used a lot by other components. And again, I'm going to add things, but this time a logger. And where is the logger I'm using? If I remember correctly, I'm using using this library, which I can see. Okay. Mm. So I'm going to use a logger from here that simply outputs to the standard output. And I'm going to use this function. And notice that this function uses the usual trick for resource acquisition and release, which is like returning a higher order function that accepts a callback with the logger. And this is where the managed monad may come in handy. So I'm going to wrap this callback in managed, okay? And it will return a value of managed logger. And I will add it to the cauldron. Okay. So now, because the constructor is not pure, because it has an effect of allocation effect, now I'll use the f function, which is the counterpart part of vol, and what okay, and now of course, okay. So how does it work? So managed here takes like a callback, the higher order function that accepts a callback, a logger callback, and takes it and returns a value of managed logger, which then instead of wire we use pure to put it into the args applicative because we don't really have dependencies of this logger doesn't have dependencies, so we can simply leave the value, and we specify that it's an f constructor, an effectful constructor, and we put it in the cauldron. And hopefully the Venn diagram should. Okay, so now we have the logger. Okay, and so we can continue here like adding things, and let's add the runner conf bin now. So in the configuration file, the runner configuration is here under the runner section, and this was the runner configuration data type. Okay, so we have to add a value of type runner conf uh, to the cauldron. Okay, so in this application, I'm using a perhaps a bit unusual way of handling the configuration. There is no global record data type for the configuration. What I mean is there is no data type that has as fields the respective configurations for each of the components. Instead of that, what I have is I load the JSON value in memory, and then each particular component parses independently the configuration from that JSON value. But there is no global strongly typed record for all the configuration. Okay, so this is a mouthful. Let me conf. Okay, so I'm using well a small library called JSON conf, and the value of JSON conf represents a JSON value in memory, and it provides a function called lookup section, which you pass the section name, and it gives you like the piece of the configuration parts that you want. Okay. So let's try that. So I need to use lookup section, and notice that it returns IO. So it's an effectful constructor. So we need to use F here. Actually, I use a variant of F called IOF that automatically lifts the the IO here to manage it. So okay, I plug lookup section here with it takes the name of the section as a JSON key, and the name of the section we saw is runner. Okay, and it doesn't. Of course, I forgot to use wire. Okay, what? Because there is a dependency on the on this JSON conf bin. Okay, which we haven't added yet. Let's see how the diagram works. Okay, so now we have the configuration bin, but of course we now need to provide a value of the in-memory JSON configuration. Let's do that. If I remember correctly, okay. So potentially we have several ways of reading the JSON configuration, like from file, from a network, I don't know. But there is an implementation which reads from a YAML file, okay? And this is here, it's here. And, okay, so I need to use make. So this constructor is effectful as well. So let's do this. JSON conf, because that's what we are adding. Is an effectful constructor in IO. I'm going to wire it as well. And okay, the constructor is called make. And we need to pass it the result of data YAML config load YAML settings. And this is data YAML config. I'm going to I'm looking here into the YAML package, load YAML settings. Okay, and what are the parameters of this? Runtime config file is to use. We only have one, which is conf YAML. Then we have any other values to use. We have none, and we have an emp usage. Okay, which well, this is a nice feature that allows you to interpolate in the JSON in the YAML file values from the environment. Yes, we are going to use them. Mm, okay. Maybe it's not imported. That, maybe, okay, maybe we need to be a bit more explicit here and specify that. No. Damn it. The commas. Okay. Literal confusion. Why is this happening? Okay, it's a list of files, not a single file. Okay. Oh, well, hopefully this bit will simplify generating all the other configuration beans because we only have to do it here once. Let's see the diagram. Okay, so now the next step, the application. So I mentioned earlier that application underscore is just a new type over the application type from way, and I have to wrap it in a new type because application is itself a type synonym for a function, and my cauldron library doesn't work well when the beans that I want to construct are themselves functions. So this is the reason there is a new type here. But let's leave application for a moment, and let's look at where the REST API is defined. And the API is defined using servant, and it's in this module. And basically, it's a regular, typical servant API using named roots for clarity. Nothing particularly groundbreaking here. And of course, here are the data types. And perhaps interesting is that I have here a data type for the links, for the type safe links that correspond to this API definition. And they are generated here in this constructor. And I have another video in my channel that explains how to create safe links for servant, and I think it's a nifty feature, and perhaps you could take a look at the video. So now that we are here, now that we are here, let's add the links to the cauldron as well. Like, okay, and it's an effectful constructor. So I call diof, and I call wire, and I'll make links, and it works. Okay, but actually I don't need wire here because the constructor doesn't have any arguments or dependencies, so I could use pure here to put the the IO comments links into the args applicative. Okay, so of course we don't simply need the links. We need actually to serve the API. And this is defined, the server is defined in this module, okay? And it's this is comment server is a new type over the actual servant server type. And again, I had to define a new type because servant servers may themselves be functions. In fact, it's very frequent that they are functions, so I need to wrap them in order to put it into the cauldron. And here is the constructor function for the API, for the comment server. And it takes the type safe links in order to, well, it uses them in order to, for example, to redirect at some point. And it takes a logger, and it takes a repository, which I think we haven't added yet here, but we will. So I'm not going to go into detail. I'm just going to mention that we are using the Lucid 2 library for generating the HTML. And also a thing that will be useful later is this function, which it applies a, a transformation each time a request is invoked in this server. Okay, it's a kind of decoration so that if we want to perform some extra work for each request in I/O, we can modify the server with this function. So let's add the server to the cauldron. So the constructor is itself pure. So let's use val underscore and wire, and let's put the okay. Okay, let's see the diagram now. Okay, so of course we haven't tied together the server and the application yet, but we see that the server being is here. It uses the logger that we already added, and the links and the repository. Okay, now let's work in transforming the comment server into the application, into the Y application itself. And there is another module called whole server that does that. It basically takes uh, a server for the API and some extra configuration and add some features like enriching the API with a static asset endpoint, which is served using this function from servant server. And it also converts the augmented servant server into the thing we need, which is the application, the Y application. Okay, and it needs like a bit of configuration, and it needs here the server API value. Notice that it doesn't take the the comment server new type. It takes here the inner value. Why? Because it really doesn't. It only needs the inner value, and if it's dependent on this, it will cause unnecessary recompilation if we change the implementation. Okay. This will make wiring a bit more involved, but perhaps it's a good move to avoid recompilation. So let's add this. So again, it's a pure constructor. So because it's a pure constructor, we have val, and then here we are, instead of using wire, we are going to use. So we are going to use the arg value to wire the arguments. And this is because we need to transform here the comment server into the thing that make application expects. We need to unwrap the comment server. And let's and this is we need to use this. Actually, we need to leave this. And I don't know why is this. The commas are the main of my existence. Okay. Actually, perhaps I should qualify this for clarity. Uh-huh. Okay. So let's see. Okay. So now we have the application here. I forgot to add the static serve configuration. Uh-huh. So static serve conf and where is it was under runner as well. So let's leave it at here. So mm, you'll notice that I'm mixing multiple configuration data types under the same section, and that is sometimes convenient. Let's see that the configuration for the server has been added. Okay. Okay. So we are making progress. The thing that's left is to actually add the comments repository. You might recall that this was the data type that represented the repository interface, and that we were going to use an Sqlite implementation, which is here. So let's add it to the cauldron. It's it was a pure constructor because it doesn't allocate anything in the constructor itself. So we use val underscore, we use wire. Okay. And let's see, component diagram. Okay, the repository depends on logger, which we had already added, and it depends on an IO connection. And from where does it come, this IO connection? So our intention is to use a connection pool, okay? And for each for each request that the server receives, we want to take a connection from the pool, and the connection will be scoped to that request, and somehow we want to magically this IO connection action to return a connection, the connection that we took from the pool. And how to do this? It's not clear how to do this because uh, how to how does the server pass down the current connection down to the repository so that the IO action now knows how to return the current connection? It's a bit how to do that. Well, I decided to use a thread local storage. Okay, so when a request arrives, uh, we take the connection from the pool and we store it a, a in the thread local storage of the thread that serves the connection, so that the repository knows how to get it. So, if you are perhaps an orthodox Haskell programmer, you may be shouting blasphemy at the screen right now, because how can you use something as unsafe as read local storage when you could use a, a reader T environment? And well, of course, you may be right, but one of the principles that I try to follow in this experiment is to don't use reader T or any other transformer in the big picture. So using thread local storage was a price that I had to pay for that. So, but okay, this is all talk, but how is that implemented? We have here this function, okay? It takes like a pool configuration, which is basically in the configuration is here, the pool size, and also it takes an Sqlite pool configuration, which is simply the database file, and it corresponds to this field. And it returns a callback, okay? Returns a callback for an Sqlite pool. So if we want to use to add the pool to the cauldron, we need to do the trick that we did it with the logger of wrapping this callback into a managed value. Okay, so let's do that. Not in scope. Uh, uh, Maybe I need to use this. Okay, so it's an effect because it performs allocation, and I'm going to wire it. But here we need to be a bit more explicit to be able to call this constructor. Usually we don't need to explicitly mention the dependencies, but now we have in order to reach the callback and wrap it into the manager. So this is a bit more verbose. Okay. So here is the pull conf. I need to add the pull conf and the Sqlite pull conf. And they are under the Sqlite section. Okay. Both under the Sqlite section. And okay. So here. Okay, so now we have a connection pool, but we still haven't tied somehow the connection pool and the IO connection to the server. Like we need to specify somehow that when a request arrives here, we need to look for the connection in the connection pool and put the thread local storage and everything. So, okay. So first of all, we need to allocate a thread local storage bin. which I have it in another project, I think. Okay, it's here. So thread local is a bin that lets you store a map of things indexed by threads. And basically we have a constructor here, make thread local. And it's an effectful constructor. So IOF, make thread local, and we wired it. Okay. But and we also specify, we also need to add the IO connection thing itself. And the IO connection, it will be a bin that is read from the thread local. Okay, so we take a thread local and return an action. And each time we execute this action, we will look into the thread local and return the corresponding value, the value that corresponds to the current thread. And if we haven't set the value for the current thread, we will throw a runtime exception. So admittedly, it's less type safe than other approaches. And by the way, because what we want to put into the cauldron is the IO action itself, not the connection, because each time we run the IO action, we need a different value. Okay, so the bin is the IO action itself. So really, it's pure here because we are not executing the IO action here in the constructor. Really, it's executed by the bins that depend on this. Okay. Okay. So now we know how to put the current connection in the thread local so that the comments repository can read it. But we still haven't devised a way to for each request to the comment server, we take the thread local and allocate from the pool and and uh, and tie everything together. Okay. I have this module here in the pool conf. This is a pool conf module that we used earlier uh, uh, to make the Sqlite pool, but there is an extra function here called hoist with connection, and it has a bit of an involved type, and it says that well, it takes the Sqlite pool and the thread local, and it takes a callback which so if you are given a way uh, of modifying a particular bin with a transformation of IO actions, if you are given this way of transforming a bin, this function modifies the bin by for each IO action that we modify, we take a connection from the pool and we put it into the thread local. Okay. And of course, what do we want to modify? What bin do we need to put here? What we want to modify is the comment server. And the way of expressing how to modify the server is with the hoist comment server function. So this is the final piece that we need. But notice that here we are not creating a bin. We are somehow decorating a bin, like modifying a bin that already exists. So this is a decorator. And the cauldron, the library, has a particular way of defining decorators for bins. So instead of giving like a plain constructor here, we can be a bit more explicit and say and specify this. And what this means is, okay, so this is a more complex recipe, not simply a constructor, and it specifies two things. One, how to build the bar constructor, like the unadorned bin. Okay, and this is here. This is the constructor that we were using earlier before. But it also lets you specify decorators. Okay, that will wrap the result of this constructor and add additional functionality. And the decorator that we want to add is the decorator that takes the connection from the pool and puts it into the thread local. So this is well as before. Wire hoist with connection, and the thing that we wanted to do here. Okay. So this is the decorator that will ensure that there is a current connection. And if you forgot to add it, we will fail at runtime. Okay, so this is a bit unusual perhaps for Haskell, but this is how I did it. And we see the... Okay, so this is the full application. Okay, so there is no component no being in red indicating that it's missing. So now we have wired the entirety of our application. So thread local. By the way, why is not comment server depending on the pool? Because I'm using a very simplified. Okay, then there are several ways with more or less detail of picturing uh, the dependency graph. And in this way, this one has a bit more detail, and it correctly reflects that the server now depends on the repository because of the decorator. Excuse me, on the pull connection because of the decorator here. So you may ask yourself, So is this all extra complexity with Cauldron worth it? Why not wire things manually? Hmm? Like, yes, of course, you can have nice diagrams, but this adds extra complexity. Why not wire things manually? So actually, I asked that myself as well. And for comparison, here is how the wiring is done like it will be done like traditionally. So this is just a do notation in the managed monad, which uh, it does everything that is done here, but in the usual way. Like, for example, uh, here is the logger, here is how to invoke the make application, and for example, this decorator here is simply creating the server here and then adding the decorator with the reverse application operator. So you may say, okay, so actually it will be better to do it manually. And perhaps you are right. But perhaps the most important thing here in this video is that the overall approach that we adopted for creating the application, not the particular magic or lack of magic that we use in the composition route, okay? So Cauldron is a library that it's only used at the composition route, and the particular components, the constructors, should not know that it exists. It exists. And so if at some point you want to do away with it, you can always do wire things manually. But I will add an argument in favor of this approach. Besides the ability to render the diagrams. One advantage of this approach, of the Cauldron approach, is that if you want slight variations of the wiring for other purposes, it's perhaps simpler to get those modifications of the Cauldron than redoing the wiring manually. What I mean is this. I have a very simple end-to-end test. Well, it's actually trivial. It's only checks that the home page loads. Okay, and it runs by, well, the test is encapsulated as a test bin, okay, which is added as an extra value on the Cauldron, and then we get the server and the test bin, and we run it. But suppose that for this end-to-end test, what we wanted to do is we wanted to overwrite the Sqlite repository and use the in-memory repository. With Cauldron, it's quite easy to do. We simply overwrite the repository in the Cauldron by simply adding it here, and because it's indexed by the comments repository interface, it will overwrite the pre-existing one, and this is all that we needed to do. Suppose that you wanted to do that overwriting with when you wire things manually. Perhaps it wouldn't be as easy, because how to do that? This is like a closed value. You can't easily. It's already tied, so to speak. So you either will have to copy all the wiring and modify it to here, put the in-memory repository here, or perhaps the wiring should take an extra parameter. I think it's in a way it's easier to do the Cauldron way, just overwriting it. Although the cauldron way is not perfect either, because yes, we have overwritten the repository, but the Sqlite pool and the thread local and bin and related bins still exist in the cauldron, and they will still be constructed even if we overwrite the repository. So perhaps the cauldron API could be improved with some function that purges that remove those items, perhaps transitively. I haven't decided yet. But okay, this is all. The main idea, I think, is this approach of structuring your application as records of functions. And the idea of having a composition root in which you wire things together. Okay? The particular way of wiring things perhaps is not that important. You can do it manually or with some extra help. But having a composition root, having the idea of a composition root of your application, I think it's quite useful when you begin uh, planning how to structure it. And this is all. Thank you for watching this video, and bye.